for the function fx, okay, part 1, find the stationary points and the nature, determine the nature. Part 2, get the function fx. Part 3, find the value of x for fx increases. Part 4, find the value of k for 3 power of x, which is plus 4x power 3 minus 12x squared plus k equals 0, have no solution. Okay, we're going to do these 4 parts. Now, step number 1, we're going to find the stationary point first. To find stationary point, this means that f dash x is 0. Okay, then we solve for x. So I'm just differentiate this first. So f dash x, okay, equal to 12x power 3 plus 12x squared minus 24x. Now, f dash x equal to 0. Okay, this implies that 12x power 3 plus 12x squared minus 24x equal to 0. I take the 12x out, so leaving me with 2x power 2 plus x minus 2 equal to 0. So 12x, x minus 1, x plus 2 is equal to 0. So therefore, x equals 0, x equal 1, and x equal negative 2. Okay, these are the x value for stationary point. So now we're going to find the y value. Of course, we need to do that. So f0, okay, you substitute 0 into the functions and you get 0. Now f1, okay, substitute value in, so like 3 plus 4 is 7, minus 12 is minus 5. Okay, so that's what I get. And then if f of minus 2, if I substitute the value in the origin for the functions, I get negative 32. Okay, so these are the points. So therefore, the stationary points are 0, 0, okay, 1, negative 5, and okay, minus 2, minus 32. Okay, now we already found the stationary point. Now we have to find the nature, determine the nature with them, what they are. Okay, so let's say f double dash x equal, okay, which is on here, f dash x is this, so we're going to do second derivative, so which is equal to 36x squared plus 24x minus 24. Okay, now I'm going to move this so that I get more space. Now I'm going to test it. F double dash 0, substitute in, it gives minus 24, so less than 0, so therefore maximum. Okay, turning point at 0, 0. Okay, then let's test f double dash 1. Okay, if you substitute in, okay, you get me 36, okay, plus 24 minus 24, that give me 36, which is greater than 0. Okay, so which is minimum. Okay, minimum turning point at, okay, at 1, negative 5. Right, one more. So now we're going to find the nature of this one, f double dash minus 2. So if you substitute negative 2 in there, okay, so 32, negative 2, which is 36 times 4. Okay, so I just 36. Sorry, I just try to get this first. Let's freeze. All right, now if I substitute the negative 2 into second derivative, I will get 36 times 4, okay, plus, okay, 4 minus, okay, 48 minus 24. So if you put in your calculator, okay, you should get 72, which is greater than 0. So therefore, minimum, yeah, turning point at or minimum at minus 2, 32, negative. Okay, so these are the points. So I got all these points already. Now part 2, okay, we have to sketch it. Now to sketch it, we have to know all these points. So 0, 0, 0, 1, negative 5, minus 2, 32, and the y-intercept is 0, 0 as well. And we're not required to do the x-intercept, okay? So we just go ahead with this. Now let me draw the axis first. So we just draw this all the way down and draw this x-axis. Okay, so this is y, this is x. Now 0, 0 is here. Okay, now negative 1, 5, sorry, 1 negative 5, I think. What is it? Yeah, that's right, 1 negative 5. So let's say 1 negative 5 here, roughly. Okay, doesn't matter, 1 negative 5. And then minus 2. Okay, so minus 2, 32 all the way down here. Okay, so now I just, this minimum, and then maximum. So I just go this way first, and I just go M next to it and curve. There you go. There you go. Okay, so this is the graph look like. Of course, I have to fill up all this information here. So this is 1, negative 5, okay, 0, 0, and then this is negative 2, negative 32. Okay, this is the graph, what it look like. Okay, now let's say second part, third part, find the value of x for fx increases. So where is fx increases? Increases, what increases mean? It means positive gradient, right? So to do this, I just highlight it for you. See positive gradient, this one, from this onward, the gradient is positive, right? This one here, and then this one also positive gradient. So therefore, the answer is x, okay, part 3. So x is between, I need to move x a bit so I got more space. So x is less than 0, okay, and greater than negative 2. Cannot be including 0 and negative 2 because at 2 the gradient is 0. Okay, so we have to exclude 2 and minus 2 and 0. So it have to be between 0 and minus 2. So, and the other one is, of course, x is greater than 1. Okay, so these are increases, okay, for fx. I just clear that one first. All right. Okay, we can do the last part now. Sorry, I just try to clear it first. There you go. All right. Now, the last part is at what value so that the fx is all positive because they have no solution. See, so if this at that number so that have no solution, that means no x-intercept. So the way to go about this is only this minimum, this is the lowest value, have to move all the way up there, all the way up here. Okay, so if this move up there, this point of course all the way up. So therefore, okay, k, okay, part 4, k must be greater than, okay, 32. Okay, now if you add 32, the point will go all the way here and up. Okay, if you add 32, something like that. But have to be greater. No solution means have to be greater than, or always positive if you like. Okay, so have to be greater than 32. Thank you for watching.